Okay, so we now need a calculator for the rest of the semester. So there is one that's good enough. If you don't have one, they're like $12, $13. You can get them about anywhere. Okay. Okay, so just some background here. Really, this chapter, number 4, on ratios and rates, is really just an expansion and an exploitation of the idea of equivalent fractions. So let's just review that for a few seconds. So here's our tape measure here. And recall that I'm going to look at right here. That is 1/2 of an inch. So I'm going to put that here, 1/2. And that is the same as 1/2. And it's the same as 2/4. And it's the same as 4/8. Whoops. So all these are lined up vertically on a number line that I made here. And so they're all equivalent. They're all the same. When we talk about ratios, we're going to use and exploit this idea. And recall, a ratio is just a comparison of two numbers that have units with them. So let's get into that. So here we go. Section 4.1, ratios. Making comparisons. So in the real world, and I'm just going to read a little bit of this. This is really for you to read. But we're inundated with tons of statistics, like the number of births, there they are. The number of deaths, there it was in 2014. Number of violent crimes, etc., etc. Household income. And the list goes on and on. All these statistics here are absolute numbers, meaning that not relative or being compared to anything else. They are simply a raw count of something. In order to make sense of these numbers, we need to put them into context by making comparisons. And comparisons are ratios. We could compare them to the total population of the United States. For example, we can get a rate of 62.9 births per 1,000 women aged 15 to 44. Now that is a ratio. 62.4 births for every 1,000 women of childbearing years. That is a ratio. It's a statistic that we can also compare over years across geography. For example, there is obviously more births in the United States than there are in Mexico. But is the birth rate, that's because there's more people by far in the United States than Mexico. But is the birth rate any different in Mexico? Because this ratio here accounts for population size. So let's just take another look at this with the graph. So we'll take a look at this graph here, which has both the raw numbers right here, how many births there were in the United States in a given year. The dark blue line is the raw number. And the green line is over here. It is the rate per 1,000 women aged 15 to 44. So they're pretty much in sync until about 1970 here. And since 1970, the rate has been declining. In other words, the number of births per 1,000 women has been declining. It was in 1970 maybe 84 85, and down here in 2015 it was down to about 60. So the birth rate, the number of births per 1,000 women has been declining. At the same time, the number of births has been increasing. So how is that possible? How is it possible for the number of births to be increasing while the rate is decreasing? And the reason is the population is growing. The number of women aged 15 to 44 is increasing. So if you want to project out the number of births, you really want to know what the birth rate is. It's an important statistic. So here's another example of a statistic to make our point. We're looking here at the 2016 federal budget. Revenues are taxes and fees and the money that the government takes in, the federal government. They took in $3.3 trillion. Spending is how much they spent, and they spent $3.9 trillion. So if you spent more than you took in, you have a deficit. Which shouldn't be a surprise to you. So of the $3.9 trillion that was spent, $2.4 trillion, which represents 62% of all the spending. The way they got that is they took, which we'll do in the next, later in this chapter, they took $2.4 trillion and divided it by $3.9 trillion, and they made that some number over 100 to get a percentage, because that's what a percentage is, and they got 62%. So 62% of all spending was mandatory, which means that it's mandated by law. Things like Social Security and Medicare are mandated by law. And here's the rest of the spending here. And the interest is what we pay to finance our deficit. So it's just another example. Our total debt was $19.5 trillion towards the end of 2016. Today, I think it is over $30 trillion, which is just an unbelievable amount. All right, so there's some examples. So in this chapter, we're going to cover comparisons like these and go over the associated vocabulary. All these comparisons that we just went over, and the other ones in the book, form a ratio. So we're going to start with ratios. So here's a very basic example. If I have 30 alpacas in my herd, and you have 50 of them, we can compare the size of our herds by forming a ratio 30 to 50. We can also write it 30 to 50 there. And we can also write it 30 to 50 here. My herd, your herd. But normally, we simplify these ratios. So we wouldn't use that. We would simplify it. And we don't use the absolute numbers. These are the absolute numbers here. We don't use those when we simplify it. And instead, we would say the ratio of alpacas in my herd to your herd is 3 to 5 by simplifying it, right? 30 over 50, divide by 10 over 10, and we get 3/5, or just cross the zeros out, and we get 3/5. We could write it like that, or 3 to 5, or 3 to 5. It's important to understand that a ratio is giving us the relative comparison, right? If the ratio is 3 to 5, saying the ratio is 3 to 5 means that for every 3 alpacas in my herd, there are 5 alpacas in your herd. So let's look at what that means and think about equivalent fractions while we do it. So we have our initial ratio 3 to 5, which is the first one right here, right? 3 alpacas in my herd, 5 in your herd. We could also express that. That means if I had 3 alpacas, you would have 5 alpacas. If. Doesn't mean I do. It means if. Likewise, if I had 6 alpacas, you would have 10 alpacas. That's another ratio. It's an equivalent ratio. 3 to 5 is the same thing as 6 to 10. It doesn't mean you had 10, but if you did have 10, I would have 6. And here's another example. If I have 9, you would have 3, 6, 9, 10, 11, 12, 15. So now we have 3 ratios. We have 3 to 5, 6 to 10, 9 to 15. They're all equivalent. Notice that. 3 to 5 is equivalent to 6 to 9, which is equivalent to 9 to 15. Doesn't mean I have 9, but if I did have 9, you would have 15 because we're maintaining the same ratio. So this is from the book. Let's assume that you know that the ratio is 3 to 5 and you know that you have 30 in your herd, or my herd. Well, how many is in the other herd? Now notice how simple this is from basic equivalent fractions. If you know the ratio is 3 to 5 and you know one of the absolute numbers like 30, you could find the other one. In this case by multiplying by a form of 1, 10 over 10. But there's another technique that we're going to look at. So we're going to stick with the same theme for a minute. And here's your first one for your workbook. The ratio of summer squash you grew in your garden to winter squash was 2 to 5. Determine the other relative ratios. Okay, well, if you grew 2 summer squash, then you would grow 5 winter squash. If you doubled the amount, if you multiplied the amount of summer squash by 2, you would multiply the winter squash by 2. If you triple the amount, or you multiply the number of summer squash by 3, right? Remember, you're basically just doing this. Multiply the summer squash by 3, you'd have to multiply the winter squash by 3. So hopefully you can see what we get. Now notice, all these are relative equivalent ratios from the number lines, right? So 2/5 is the same as 4/10, which is the same as 6/15, which is the same as 8/20, which is the same as 10/25. So if you grew 35 winter squash, that was the absolute number that you grew, and you knew what the ratio was. How many summer squash did you grow? Well, the only thing you got to be careful is when you set up these ratios is that you list the units so you know what you're doing. So let's use 2/5, and that is summer squash to winter squash. So that's going to equal, I don't know how many summer squash to 35 winter squash. Notice I have summer, winter, summer, winter. Now I'm just going to multiply the denominator, the bottom number, by 7, because 7 times 5 is 35, so I have to multiply the top number by 7, and I get 14. So there'd be 14 summer squash. So finally here, there's a thought question, and it says, does it matter which of the relative ratios above that you use? So in other words, does it matter which one of these that you use to solve this problem? And the answer is no. And I'll just randomly pick one. Let's say, I don't know, 4 over 10. 4 over 10. And that would be summer to winter equals some number over 35. And that's summer to winter. And here you're probably saying, okay, well, what do I multiply this by? Well, I can multiply it by 3.5 and multiply the top by 3.5, and if you put that in your calculator, you're going to get 14. But this does bring up a point. And the point is that we're going to have things like this where it's not easy to see what to multiply by. So we have another technique, and we're going to call that our fundamental technique. And we're going to go over that right now. So I'm going to basically repeat 4.2 in the book and just use different numbers. This is developing our fundamental technique. So let's start with this. 5 over 6 equals x over 6. So what is x? And you probably guessed correctly that it's 5. If the denominators are the same, you can just basically ignore them. Let me do another one like that. How about x plus 4 over 12 equals 3 over 12. Oh, let's make that not 3, but 8 over 12. So in this case, what does x equal? And hopefully you said it's equal to 4. Again, if the denominators are the same, you can ignore them. So let me erase this and get a clean board. So now let me do x over 7 equals 3 over 4. Okay, this one's a little bit hard. I don't know what to multiply 4 by to get to 7. And let me just show you what I can do. I can multiply this side by 4 over 4. And I can multiply this side by 7 over 7. And that's going to give me a least common multiple of 28. And being that I have that 28 on both sides, in other words, being that I have this, I can simply ignore the denominator. And what I'm solving now is 4x equals 21, divide both sides by 4, and I get my answer, 5 1/4. But notice what I did here. So really what I wound up doing is multiplying 4 by x and multiplying 7 by 3 and ignoring that ignores the denominators. So that's called cross multiply and divide. And it's really good for problems where you can't see how you can easily get to one equivalent fraction to the other. So here's the problem we'll want to solve. And let me get the white pen. So we're going to solve this problem here. Recall from whenever that if you multiply the denominators together, you can find a common multiple. So, in other words, if I took the left side of this equation and multiplied it by that form of 1, and I took the right side of the equation and multiplied it by 7 over 7, I would still have an equality, right? Because it won't change the equality if I multiply both sides of the equation by 1. So All I have to do now is just say 1/2 times 28 equals 7 times x. I can ignore the denominators because they're the same. So essentially I multiplied 28. My original problem is 1/2 over 7 equals x over 28. I can multiply this side of the equation, just the 1/2 by 28, and the other side of the equation I can multiply by 7. And that's how I get that. So that's called cross multiplying. Now 1/2 of 28 is 14. So I can multiply, cross multiply, and then divide. Obviously I'm going to divide by 7 because 7 over 7 is 1. X then equals 2. And so that shows the technique of cross multiplying. This is our fundamental technique. This will work obviously every time. So this would be example 4.3a. Use black here. And I had to make a couple changes because it's she. Anyhow, Marchetta took a trip to Mexico. Upon leaving, she decided to convert all of her pesos back into dollars. How many dollars did she receive if she exchanged 300 pesos at a rate of $5.30 equals 11.1 pesos? So here is the rate. $5.30 to 11.1 pesos. So that's our ratio. Now I'm going to do this two ways. The first way is the way we do equivalent fractions. Like 1/2 is how many eighths multiplied by 4 over 4. And 1/2 is equal to 4 eighths. This is a little trickier because I got to find out what do I multiply 11.1 by to get 300. Now recall from 5th grade, back family. For example, 8 divided by 2 equals 4. Therefore, 4 times 2 equals 8. I'm going to use the same idea here. So 11.1 times what number equals 300? 300 divided by 11.1 is going to equal 27.027. So if I multiply the denominator by 27.027, I'm going to get 300. So I have to multiply the numerator by the same number, because 27.027 divided by itself is 1, so I'm really just taking this ratio, multiplying it by 1, and I'm going to get the new ratio here. So now all I've got to do is 530 times 27.027, and I get 143.24. And notice how I set these ratios up. Dollars to pesos equals dollars to pesos. This is the relative ratio here, and this is the amount of pesos that we actually had. Now this is a long way of doing it, but it's still beneficial to look at this because it comes up sometimes. Now this one here, we're just going to do with cross multiply and divide. This is our fundamental technique. Cross multiply and divide. So I'm going to cross multiply. Notice I set this up. This setup here is called a proportion. And a proportion means that each ratio is going to be equivalent. An equivalency between ratios. So cross multiplying, I get 530 times 300 is going to equal 11.1 times X. Now hopefully you know to divide by 11.1. That gets X by itself because they cancel. So you have to do it to both sides. And I'm going to get the amount of dollars is equal to, again it would be 143.24. So $143.24 is the equivalent of 300 pesos. Notice, just like in a fraction, this ratio here is equal to this ratio here. So this problem is a little bit tricky and you got to be really careful. I suggest you read 4.4 in the book. It goes into more detail. So it says, suppose a local school has 1,131 computers consisting of a combination of laptops and desktops. The ratio of laptops to desktops is 5 to 8. So that would be 5 laptops to 8 desktops. How many laptops and how many desktops does the school has? How many do they have? So we cannot directly solve the above problem. So I can't set up a proportion like this. And think about why that is. Well, recall from the last problem I went peso or dollars to pesos equals dollars to pesos. This states laptops to desktops equals laptops to computers. No, this is not the same. But what we can do, we can use the ratio of laptops to desktops, which is 5 to 8. We must find the ratio of laptops to computers. And the way we can do this is laptops to desktops. We can add these together and we get 13 computers. Because computers consist of either laptops or desktops. So if I add these together, I get 13. So my ratio of laptops to computers would be 5 to 13. And that's laptops to computers. And the ratio of desktops to computers would be 8 to 13. Desktops to computers. Now this will work. 5/13 is, if I had another equivalent ratio, like 10/16, for example, that would be laptops to desktops. If I add these together, I get 26 computers. And the ratio of laptops to desktops would be 10 to 26, which is the same as 5 to 13. See that? 10 to 26 laptops to computers is the same ratio as 5 to 13. They're equivalent. So you can add these together. By adding them together, you get to the total, which is computers. So for laptops, I have 5 laptops for every 13 computers. Laptops to computers equals, I don't know how many laptops, but I do know I have 1,131 computers. So I can cross multiply, which is going to give me 5 times 1,131 equals 13 times X. And then divide by 13 here and by 13 here. Now let's go on our calculator and see how many laptops we have. And I'm getting 435 laptops. Now I could do the same thing with desktops using the ratio here. 8 to 13, which is computers to, desktops to computers is X desktops or 1131 computers. But if we look down here at the thought question, it says, do we need to have these two proportions? Otherwise, this one here and this one here. Or can we solve it with only one? In other words, are we really solve it right here? You know, once we know we have 435 laptops, it should be clear that I can just take 1131 computers, subtract the 435 laptops, and I'm left with desktops. So I don't have to go through this here. And the answer there. So this is the last one we're responsible for, 4.5a. It says a quarter-pound lobster tail costs $6.99. How much would it cost for 3 pounds of lobster tails? So here is our first ratio. And it doesn't matter how you set it up. In other words, you can go dollars per pound, or you can do pounds per dollar. As long as you keep it straight, it doesn't matter. So let's do dollars per pound. So I got $6.99, whoops, $6.99 per 1/4 pound. And that's going to equal, I don't know how many dollars for 3 pounds. Right, so I'm going to use the fundamental technique because it's easier, right? So I just cross multiply. 3 times $6.99 equals 1/4 times X. Now, if you want to put it on your calculator, you could divide by 1/4. And then you have to divide this by 1/4. Be careful how you put that on your calculator. You might know that that's 0.25, and you can also divide it by 0.25. Or you could just multiply this side by 4 and this side by 4. Because 1/4 times 4 is going to be 1. So you just get X. But either way, you have a few options. So let's figure out what it is. And I'm getting $83.88. And it won't matter which of these ways you do it. So here is homework problem number 1. And it says state whether the information give is or is not a ratio. So you want to decide whether or not these are ratios. The first one is done for you. It says, is it a ratio? And the answer is yes. Because that P stands for per, miles per gallon. And per means divide. It means a ratio. And it has two things. It's sort of like you could look, this is the thing 1, it's the numerator, which is miles. And thing 2 is gallons. So this would be 32 miles per 1 gallon. 200 acres. Well, no, it's just a number. It's just a quantity measuring something. So the answer is simply no. So you're not going to have a thing 1 and a thing 2. So that's how you can figure this out. So problems 2 is just solving by cross multiplying and dividing. That's the easiest way to do these. Pretty simple. This one I wanted to help you a little bit. Here, you're still cross multiplying and dividing, but you got to multiply 10 times x plus 3. That's 1 cross. The other one is 7 times 30, which is 21 with the 0. So this one you'd go 10 times x plus 10 times 3 equals 210. And step 1 would be to subtract 30 from each side, and step 2 would be divide by 10. These here are just trying to find out if they're equivalent. So I'll look at this one with you. This one This is always the numerator, and that's the denominator. So I got 15 over 10. Is that equal to 30 over 2? This should be pretty clear that 30 divided by 2 is 15. And 15 divided by 10 is 1.5. So no, they're not equivalent. Okay, I'm just going to give you a couple hints on these. Number 5, in a scale drawing, a flagpole is 40 feet tall and is drawn 2 inches high. It's a scale drawing, right? Like an architectural drawing. So there's your ratio, and you can either go 2 inches to 40 feet or 40 feet to 2 inches. And we're going to set up a proportion, and it's going to be feet to inches, feet to inches. So you should probably figure out where that one goes, right? Car gets 28 miles a gallon. There's 28 miles. This one I want to go over a little bit. 28 miles per 1 gallon, right? They don't put in the 1 gallon there, right? When you go to the store and you're going to buy gasoline at the gas station, it says $2.15 or whatever it says. What it means is $2.15 for 1 gallon. Right? They don't put that on the sign. So there's one proportion, and the other proportion, you just got 100 miles. So where does that go? Yes, there, you're right. And that's what you're solving for, X gallons. So it says a large 24-inch can of soup costs $3.25. What is the cost per ounce? They say that, they mean 1 ounce. So let me set up a proportion, although there's 2 ways to do this. I have $3.25 for 24 ounces. And what I want to find is how much it costs for 1 ounce. Now you can cross multiply and divide. But the other thing you can do is just divide this. When you divide 2 numbers, you're going to get 1. But the bottom number is always going to be a 1. Like for instance, 8 divided by 2 is 4. But if this is a ratio, the bottom number, the denominator, never goes away. So that would be that. So you can just divide these and then put a 1 over it, or you can cross multiply and divide. Now ounces per dollar, you could just use the same ratio. And here you want that, and that's what you're solving for. Cross multiply and divide. Okay, so problem 8 here is what to get you started on it. Determine if n, which is in each of these things here, must be larger or smaller than 3200 in order to make a proportion. That means you want this to be equal to this. So does n, you just want to know if it has to be larger or smaller than 3200. You're not supposed to solve these, just use logic. So, in other words, I'm not going to cross multiply and divide. I don't want an answer. I just want to know if n is greater than or less than or equal to 3200. Well, if 3 is less than 5, then n has to be less than 3200. So it's less than 3200. That's an odd 3. So in this one here, if 3 is 3200, 5 is greater than 3, so n has to be greater than 3200. So in this one, n is greater than 3200. So I think you get the idea there. This one I want to go over. This is the last one I'm going to go over. So number 10, I think 9 and 11 you can handle. So in a community in Florida, people over 60 years old and older outnumber people under 60 by 3 to 1. If there are 800 residents in the community, how many are under 60 and how many are over 60? Well, here's something you cannot do. 3 greater than 60 to 1 less than 60 equals how many greater than 60 to 800 total. See the problem? Greater than 60, less than 60, greater than 60 total. Doesn't work. Now recall, if I add these two together, I capture everybody. So 3 plus 1 is 4, and that would be residence. And I can find greater than 60 by saying 3 or greater than 60. That's the ratio for greater than 60. And that's going to equal, and I'll let you fill that in.